How to solve absolute value of x is greater than -2 using an algebraic method. Graphically, we can see that the solution would be x being all real values. However, I can't seem to get the answer while trying to solve it algebraically. I was thinking about squaring both sides and get the following inequality. Okay, let's have a look. So first, for absolute value of x, we can write that as square root of x squared. That is correct, I agree. And then, if we square both sides from here, it looks like we will have x squared is greater than 4, and then move that to the other side, and then factor it x minus 2 times x plus 2. From here, we can say we care about 2 and -2. Or you can also look at the graph of this, but we're not trying to use any graphs of the parabolas, so I'm just doing it with the number line test. From here, -2 and 2, if you plug in a number less than -2 into here, you end up with positive result. Plugging a value from here, that's a 0 into here, you get a negative result. Plugging a number bigger than 2, that's a 17, into here, you end up with positive result. So from here, we get x is less than -2, or x is greater than 2. But this is not correct, because the answer to the original inequality is x being all real numbers, meaning going from -infinity to positive infinity. Right here, we are missing this part. So where did this go wrong? Let me tell you. We have to be careful when we square both sides of an inequality. Here is the example. On the right hand side, let's say we have a -2, and on the left hand side, let's say we have 1. 1 is certainly bigger than -2. Then let's take a look. If I square both sides, when I square 1, I get 1. When I square -2, we get 4. Now, 4 is actually bigger. So have a look. Whenever we square both sides of an inequality, if one side is negative, you just have to be really careful. Sometimes the inequality will have to be switched, but we didn't address that right here. So, what can we really do to solve this inequality algebraically though? I think I would just go with the original definition. In my opinion, it's not the best, but let's still take a look. Here is the deal. Right here, when we have absolute value of x, let's say it's greater than some number a, then in that case, we can take out the absolute value and then just say x is greater than a, and we do have another part to worry about, or we have to worry about x is being less than -a. So if you just apply this right here to that, it will work. Let me show you. Absolute value of x is greater than -2 implies take out the absolute value and then just still maintain the greater than and then still maintain this number, which is -2. And the second part right here is or take out the absolute value but switch the inequality and then negate this number here. So we will have negative and then -2. This part is done, but this right here is saying that x is less than 2. Now, combining these two inequalities, and this is an OR situation, have a look. X is greater than -2, meaning if you look at the graph, it's an open circle and then we go all the way to the right. X is less than 2. Let's say 2 is right here, and open circle and then go all the way to the left. This is an OR situation, so we are going to union, meaning kind of put together of these two inequalities over the graph. So whatever this have, you also put together with that. So altogether, you can see that because this right here goes all the way to the right, so you cover this. This right here goes all the way to the left, so it covers that. So altogether, this implies x is going from -infinity to positive infinity. So I will just look at the graph for you guys like this. It's just like this. So I don't know if people like this notation or not, but sometimes it works. Sometimes people don't like it. Anyways, it just means all real numbers.